All right. Good afternoon, everyone. Welcome to the very last presentation of the day here at the Solution Showcase. You'd think by saying that all day today, I would have had it right. I would like to bring up our last presenter for the day. Thank you for being with us. My name is Michael Galbincia. I am the Manager of Education Programs here at IFT. And we're going to close out the lineup today by discussing a topic in a forward-thinking session that's going to go over how cutting-edge data science is reshaping our consumer insights and product research. This presentation is sponsored by Simulacra, a synthetic data studio, and it introduces a new approach to predictive analytics, causal AI powered by synthetic data. Where traditional market research can be slow and expensive, and generative AI tools often lack structure or evidence, causal AI gives us a way to model cause and effect, simulate real-world interventions, and generate statistically valid predictions at speed. Please join me in welcoming Jason Cohen, founder and CEO of Simulacra, and he will explain how CPG teams are using this technology to accelerate product testing, reduce, rework, and bring more foresight into their decision-making without sacrificing rigor. All right, before we dive in, I just want to give you a quick reminder that at the end of the session, please make sure you scan the QR code that someone's walking around with or at the table. You'll be entered into a drawing and enter prizes, or you get points that you will then get prizes for. So that being said, without further delay, let me bring Jason up to the stage. And as always, we'll have a little Q&A session at the end. I'll have a microphone. I'll run it over to you and you can ask any questions you have. So all right, let's give a round of applause for Jason.
Thank you. Hi, everyone. Thank you all so much for joining me. I'm Jason Cohen, founder and CEO of Simulacra Synthetic Data Studio. Many of you might remember me from my prior role where I was founder and CEO of Gastrograph AI. Gastrograph AI, I'm happy to say, was recently acquired this year by Nielsen's IQ, the Bases division, in order to power their creative product AI. So I have deep experience, more than 10 years, more than a decade of experience building AI for CPG. And it was the challenges that I faced there and saw throughout the industry that inspired me to start this new company, to start Simulacra. So what I want to do in today's session is I want to talk about synthetic data, what it is, its promises, its pitfalls. And then I want to talk about the limitations of LLMs and why you potentially shouldn't use LLMs for your consumer and market research data. And finally, I'm going to show you a demo of Causal AI, a new model architecture that we've developed that solves many of these challenges and others faced within the industry. And we're all market researchers here, so I'm going to end on a validation. So we can jump right in. What is synthetic data and why should you use it for your market research? Well, if we ask Dr. Google what is synthetic data, it'll come back to us with something it calls an AI overview. This is a form of generative AI. It's actually, this text wasn't written by a person, it's written by one of their language models. And it says synthetic data is artificially created data that mimics the statistical properties and patterns of real-world data. It's generated through algorithm simulations or AI techniques rather than being collected from real-world or human inputs. So if we could use this data for our consumer market research, this would be wonderful. This would solve all sorts of problems inherent throughout the industry, right? And those problems are that this research is expensive. You're frequently spending upwards of $50,000, $80,000, $100,000 per study, upwards of $6 per complete if you're doing any type of CLT or product testing. And frequently, this data comes back with limited coverage. You can't always do cohort analysis. You don't always have the sample size in order to do cross-tabulations on specific consumer cohorts of interest, or even areas where you got directional results, but not enough statistical power. And part of this is that the majority of research, in our experience, the majority of research returns no statistically valid findings. You can't reject the null hypothesis. You can't say that this product is better than the competitor. You can't say that this prototype is better than the current version. You can't say that this brand's intrinsic advertising resonates or that this marketing campaign works. And this is, again, this is true more than 50% of the time. So if we had a magical black box that we could put in our questions, right, and say, what do people think of my product, right, or what do people think of this ad, and get back reasonable, manageable, usable results that was actually predictive about consumer preference or consumer opinion, this would be amazing. But the question is, and the question that we always get, which is the right question, is synthetic data fake? Can we trust it? Can we use it? Can we make decisions based off synthetic data? And I think the answer to this might surprise many of you, but the answer is synthetic data is not fake. Synthetic data is as real as its application. So if you are like me and you use ChatGPT or Claude or Gemini, and you've said, I'm not inspired. I need help writing this email, or I have this really long paper to read, right? And you toss it in to summarize it, or you say, this is an important email. I'm going to use it to copy check, or give me bullet points for a presentation, right? These things work. They are helpful. We like using them. And not only are they working, right, but they know things. Here I asked ChatGPT, I said, summarize Moby Dick in 3 to 5 sentences in the style of a Shakespearean sonnet. And it comes back, a captain fierce, obsessed with vengeance deep, pursue thy ghostly whales through thy ocean's might, right? This is amazing. If I had given this to an intern or to a colleague for some reason, and this is what they came back with, I would be ecstatic, right? And so we're learning to trust these models. And one of the areas that we've seen the most success in is in AI software development, is in using LLMs to help us develop software. You ask the AI to improve or change or update something in your software, and it writes code. And that code runs just as real as if a human had written it, right? But the difference there in all of these examples is that there's some sort of verifiable ground truth. So unlike your consumer research where you don't know the results before you run the study, right? In these scenarios, you have something that you can test. You can read the email, you can edit the draft that it gives you can edit the summary, or you can test if the code runs. But this is not really the case for your consumer research or your market research. And part of this is the data that these things are trained on and the difference in the data between how these models learn and how your consumer and market research operates. So these models are trained on predominantly unstructured data. In the case of LLMs, large language models, this is unstructured text. It's trained on the internet's corpus of text, right? What people have written online. But your research is predominantly structured data. And not only is it structured, it's tabular. So tabular data is where rows are observations and columns are variables. And what I'm going to argue in this next section and hopefully prove to you is that LLMs are a poor choice for tabular data, that you should not be using Claude or Midjourney or any of these other LLM-based models in order to generate and analyze your tabular data. And in fact, I'm going to go as far to say that using LLMs for synthetic data generation, for synthetic users, or for digital twins is a form of catastrophic failure. Now, why is that? Well, the data that these models are trained on is biased. The data that they do have is negative, and you and your vendors don't have enough data to correct this. So let's go through this. How are LLMs trained? Well, LLMs are trained starting with nearly the entire textual corpus of the internet. They've grabbed just about anything anyone has ever written online, and they run that through some very expensive computing equipment. This is what's driven the cost, the market share of NVIDIA up to $4 trillion. Right? So they run this for originally it was weeks and weeks and weeks, and now it's months and months and months. And at the end of that, what you get is something called a foundation model. Now, a foundation model is an LLM, but it's not a usable LLM. Before these LLMs can be used, they need to be shaped. And generally, that shaping is done through something called reinforcement learning for human feedback, or reinforcement learning from human feedback. So if you've ever used any of the big chat models, ChatGPT or Claude or Gemini, and you've given a thumbs up or a thumbs down to a response, that is a form of reinforcement learning. That is helping shape the AI. And we now know just how important that is because we've seen what happens when someone removes all of the post-training, post-training from it. If you don't know, look it up. But think about how different this is from your data. When you're running consumer or market research, you are asking important questions about the consumers, right? There's information about the consumers, their behavior, their psychographics, their demographics, their lifestyle that are important to making decisions about your product, your company, your brand. But if you compare this to text on the internet, right? Here's an example of text on the internet. Coke does something to their cans. That first sound, unmatched. Instant serotonin boost. Pepsi could never. I don't care what anyone says. Coke in a can is superior. If you know, you know. Right? Who wrote this? Who wrote this? Right? We don't know. Maybe we can guess that they're younger. They certainly used a lot of acronyms. Maybe we can guess that they're Americans from the United States, but maybe not. Maybe they're just steeped in American culture. But we really don't know the gender. We don't know the ethnography. We don't know the purchasing habits. We don't know the income level, education level, family size. We don't know any of those attributes that you care about when you're doing your market research. And this is true for this example, but this is true for basically all of the text on the internet. It's not linked back to any of the consumer attributes that you care about. And not only is that a form of bias, but there are other forms of biases inherent in the training data. You have demographic biases, where not every demographic writes the same amount of text or about the same things on the internet. There's confirmation biases, where depending on how you prompt an LLM, you'll get data and information that is confirmatory to your question. There's temporal biases around when these were trained and when the training cutoff is. Cultural biases, linguistic biases, just about half the data that these models are trained on is in English. And of course, ideological biases. So not only are these models biased based on their training data, but they're also biased based on their tuning. So all of the big model providers, we talked about that thumbs up, thumbs down for reinforcement learning from human feedback, all of the big model providers need that. And there's not enough of you giving thumbs up, thumbs down in order for them to launch these models. So what do? They outsource it. And they outsource it predominantly to India and the Philippines, and to a much lesser extent United States, but only for things that are physics and math questions, domain expert users. And what these individuals do is they generate hundreds or thousands of responses per day, and they vote them up and down, and they say, we're trying to train these models to be happy and helpful and chipper. Some people even call them sycophantic, right? Whatever you put into them, they'll tell you, oh, what a great idea. You are so insightful, all right? But are your consumers, are your target customers happy and helpful and chipper and sycophantic about your product, right? Of course not. And there's no reason to believe that these biases end after this prompting. These are biases that are inherent in the model. So the data is biased, but not only is the data biased, the data is negative. We've actually already tried this. We've all already been through this business cycle, all right? Every major CPG has tried social listening, and every major tech company and market research firm that had a social listening division has sold it off or shut it down, and it's because it didn't work. Nielsen sold off its social listening in 2020 for just $6 million. Right? Whose brand here is worth more than $6 million? Kantar sold off its reputation intelligence and an advertising intelligence, the social listening divisions 2022 and 2023. Apple shut down Topsy in 2015. And the problem was data quality and data availability. On data quality, you had bots, you had trolls, and you had complaints. Now, maybe you think that you could have filtered or screened out the bots and the trolls, but you can't deal with the complaints. Particularly in English, the only reason that anyone writes online about a CPG product is to complain. Right? Complaints outnumber neutral and positive sentiment online 3-to-1. And so the only reason someone feels compelled to write about Doritos is they had a bad experience somehow. Right? And so this is not the data that you want your models about your products trained on. The second part of this is data availability. Even if you wanted to, this data is not available anymore. Every major social media company, whether it's Twitter, Reddit, Facebook, has shut off API access. They're now hoarding all of that data, so it's only used in their own models, but that doesn't matter anyway because the youngest generation has moved to what's called dark channels. They're posting only on things like Snapchat and WhatsApp groups where this data is not publicly available. So we've been through two parts of this. The data is biased, the data is negative. And now one of the most important parts is that you and your vendors don't have enough data to fix this. So there's a lot of companies out there right now that'll tell you, well, we're training our own LLMs. We're taking our proprietary data, our decades of proprietary data, and we're training an LLM, or we're combining your data and our data, and we're going to train a custom LLM model that solves this. And I'm sorry to tell you that is just not the case. It cannot be the case. These models require a level of resources that no company focused on CPG has. So this is a quote for Anthropic. That's the company behind Claude, one of the big three model providers. They said that they spent $100 million training their current frontier model, that they're in the process of spending $10 billion right now to train the next generation model. And they're planning to spend over $100 billion within the next 3 years to train the model after that. So there's no company out there that's training a custom LLM or their own LLM. When they say that, what they actually mean is that they're doing fine-tuning. Now, fine-tuning is a commodity service. You can pay ChatGPT or Claude to fine-tune on your data. You could, if you want to do it open source, you can grab a Llama model from Facebook and do it on AWS, or you can do it on Azure. All right, but what the idea behind this is sound. The idea is what we're going to do is we're going to show the AI examples of our data, and we're going to get it to learn from our data, and then when we ask it future questions, it'll be able to respond intelligently about it. And at first glance, this seems like a good idea. If you read the AWS docs, how much data do I need to do fine-tuning? It'll give you pretty good news. It'll say you just need 100 observations. But there are some caveats, right? Where did that go? There we go. You need just 100 observations. But there are some caveats, right? That's true only if the fine-tuning is simple, it's related to tone or process, and the output is text. So if you want to train an LLM to sound like American Express Platinum Concierge Desk, or you want to train it to sound like a maitre d' at a fine French restaurant, you can do that, 100 observations, that'll work. But as soon as the complexity increases even marginally, your data requirements increase exponentially. And so a simple pass, fail, accept, reject, now that takes 1,000 observations to train. But again, your data isn't a simple pass, fail. If you're doing consumer or market research, you have a lot of consumer attributes and outcome variables that you care deeply about, right? That's what you're trying to make decisions on. So we could look at the docs from Gretel. Gretel was a leading provider of tabular synthetic data generation using LLMs. We consider them to be a partial competitor to us. Gretel was just acquired by NVIDIA March 2025 this year. Congrats to them. And if you read their docs, they say that they need 10,000 observations to train an LLM to generate this type of tabular structured data. Now, let me ask you, do you have 10,000 up-to-date relevant observations about the specific target research, the specific target group that you're researching? No? Does your market research firm? No. And if they did, or if you did, why would you need synthetic data? So in summary, the data is not linked for LLMs. The data that's available to train on is not linked to the consumer attributes that you care about. Of the data that they do have, it is biased and it is negative, and there's not enough data to solve this. And so the problem here is that we've all seen LLMs work. We've seen it help us write the email. We've seen it help us summarize a document. We've seen it give us good ideas for use in a presentation. We want it to work. We like it when they work. And so we take that belief, that trust that we've developed in seeing them work over time, and we bring it with us to work. We say, well, maybe I can put in my data set and I can find some information out about what consumers think about Pepsi. And the reason that I call this catastrophic is because when you do it, it looks like it's working, right? And yeah, this is how they're selling it to you right now, right? This result that I'm showing, this is the result of a Turing test. A Turing test tells you, is a test that tests whether you can tell whether text was written by a computer or by a human. And up till February of this year, we could tell. We knew when a text was written by an LLM or some other model, but now we can't. And that means that that gut check, that this looks good, is no longer enough to know if it's working, and it's very easy to be tricked by the outcomes of this model. So in response to this, what we've done is we've developed a new model architecture that's specifically tuned to consumer and market research. The idea behind this model, we call this Causal AI, is that Causal AI is trained exclusively on your specific piece of research. It's trained zero shot, so it learns all of the internested relationships, it learns all of the causality within a data set, and it uses that ground truth to build up a new or larger data set without any hallucinations, confabulations, or without outright lying to you. And the predominant use case of this is scenario modeling. It's the ability to say, well, what if we had gotten more married men or more high-income women in this data set? But the most powerful thing that it can do is you can simply ask for the results that you wish that you got in that study. So if you ran a study and you wanted your product to be at the top of the preference stack rank, you can now go in and you can say, well, what would I have had to do in order to get that outcome? And what this will do is it'll generate for you the most likely path. So there's a lot more that I could say about this, but I think the most helpful thing I can do is do a demo. This is a real-time demo. I'm controlling this right here, so none of this is rehearsed. This data set, this is a product development data set. So we're going to be looking at consumers and consumer attributes along with sensory data. And 860 observations, medium-sized survey, 37 variables. And the interesting thing about this data is here we have 4 market products, A, B, C, and D, plenty of data, 200 to 230 observations. But we have one prototype, prototype X. This is a prototype that's under development. And our goal in this demo is in 90 seconds or less is to find a new demographic target and a new flavor profile optimization for this prototype, 90 seconds or less, right? Before I do that really quickly, this data is almost 50-50 men versus women. We're evenly divided across decade-long age cohorts. This data set is 67% category users. The category is canned beans, very exciting category. Again, evenly divided across kids, single, and dual income, no kids. What I'm going to do now is I'm going to split, this is our empirical data, by sample, and I'm going to filter by liking, and I'm going to sort by mean. And we can see here that samples C and B are at the top of the preference rank. They have the highest liking scores. Samples A and D are at the bottom, and our prototype of interest, prototype X, is at 6.83 out of 10, right smack dab in the middle. So what I'm going to do now is I'm going to take this 860. I'm going to bring it here to generate. Our default generation size is 1,000. That's not that impressive. Let's up this to 5,000. And before we run a scenario model, before we try to optimize this product or find that demographic target, let's just make sure that the AI has learned and can generate this data. So here we've requested 5,000. We got 5,000. We're at 100% unique. This is a great indicator for data quality. And you can see now that this n equals 5,000 data set is the identical structure and format of your starting data. So you can actually download this and use this exactly as you would your empirical data, now with the statistical power of n equals 5,000. And that's very important. No other form of synthetic data generation, no other form of upsampling, downsampling, data abstraction increases statistical power. But what Simulacra is doing is it's actually learning from the entire data set, every cohort, every subpopulation uploaded here, in order to predict for every subpopulation and cohort within the data set. And what I'll do now is I'll prove to you that this is in fact statistically identical. So if we look at sample A, we started with 230 empirical observations of sample A, 27% of the data. We generated 1,354 observations of sample A, 27% of the data, for a delta of 0. And as I scroll down here, you can see that just about everything is between 0 and 1. The intuition there is that if you were to rerun the same survey again at n equals 5,000, 6 times the data size, you would have a minimum natural variance of 1 or 2% across the board. But in fact, we're actually hitting it perfectly. Our mean absolute delta is 0%. Now, just as important, potentially even more important than these univariate distributions is let's once again look at liking scores and make sure that the AI has learned to replicate these distributions in liking. So I'm going to filter here, and here we can see sample A, empirical score of 6.74, predicted score of 6.66 for a delta of negative 0.09. That's on a standard deviation of 2. Right? So incredibly accurate overall, 0.09, 0.14, 0.23, 0.05, 0.5. All right, so we've seen now that this is working. Now to deliver on that promise, what we're going to do is let's set this to 1,000, and we're going to request a scenario model where everyone tasted sample X and everyone liked it. And to do that, all I have to do is put in sample and liking, and I'm going to say I want a data set of 100% product X, and I want a data set where everyone gave product X between a 7 and a 10. And what this is going to return to me is the most likely path to that outcome. We'll be able to see the differences in both the population and the flavor profile of this product in order to achieve this result. And so here I've requested 1,000, I got 1,000. Just think how long it would have taken you or how expensive it would have been to get 1,000 completes on people who tasted product X and gave it between a 7 and a 10, right? And yet here you can do it in real time at perfectly high data quality. Now, only 2% of your starting data, only 2% of that 860 fits that constraint. So what we can do now is we can look back at these tables and we can see what's changed. So here we are now at 76% women. That's a 25% women increase. So women like this product more than men. We've zeroed out 50s and 60-year-olds. This is a product that's going to be preferred by 30s at 41% and 40-year-olds at 39%. Those are 19% increases. Majority of these individuals are single, and the majority, great majority, 82%, are category users. Right? So already this is amazing. We can use this and we can hone in on who's going to like the product. We can hone in on who we should be marketing and targeting to. But beyond that, we can also look at the deltas here and see what we should change about the product to optimize this for them. So here we have negative 0.8 on aftertaste, so we have to reduce aftertaste, sweetness, sweet aftertaste, herb flavor. And on the other side, we need to increase bitterness, clearance, herb aroma, tomato aroma, garlic flavor, tomato flavor. Now, one of the things that's most powerful about this type of scenario modeling is that you can do iterative insights. If you were responsible for this product and you said to yourself, well, wait a minute, if the majority of the people who like this product are women and they're category users, can I just target women category users? And the answer to that is, of course. So here we can just add this information into the scenario model. So we can request an updated data set where it's 100% women and it is 100% category users. And if we run this, we will get back a new scenario model that meets these constraints. So now only 1% of our starting data, only 1% of that 860, that's 9 individuals, meets this constraint. Should you make brand-defining or company-defining product decisions about from the results of 9 individuals? Probably not. Right? And so this is a way that even if you don't have the crosstabs, even if you don't have the base size in order to do this, you can make robust data-driven decisions. And now you can see that other things have changed, right? We're still up on 30-year-olds, 60% singles, and these other things have shifted as a result of this. So there's a lot more that we could say and do here, but in summary, this can be used not just on this type of product development data, but on any type of consumer or market research that you're currently doing. We have companies that are running A&U studies, purchase intent, hedonic preference mapping through this. We have companies that are running brands intrinsic advertising and other types of marketing data. And of course, we have pricing and promo optimizations, companies looking at how they should price products or optimal discount times and timelines. And in aggregate, what this does is this meets the promises of synthetic data without all of the pitfalls of LLMs. It answers these infinite what-if scenario models. You can use this to dramatically reduce your research costs. We have a lot of companies that cut their base size and ongoing data collections in half by using simulacra. I'll show you a validation on that in a few slides. You can refresh and find results in prior research where you weren't able to make decisions. And in aggregate, in the end, what this does is it increases time to insight and speed to market. So as promised, this has been validated. Everyone wants to know, how do we know that this platform works? We've done a number of different validations, all of them blind, properly set up. Usually in collaborations with customers. One of the ones that I'm most excited to share is this data reduction validation study. We took a data set of N equals 2,782 people, and they said, how little data do you need to reconstruct the results of the entire data set? Right? How little data from this overall survey can you use and still predict the entire outcome? And amazingly, we were able to sample down to just 500 observations. That's an 82% reduction in base size, and reconstruct the results of the entire survey with no meaningful increase in error. So this is confirmatory. This is validating that the platform can, in fact, when you start with whatever base size you have, predict out to a broader population. And it is confirmatory that this allows us to run predictive scenario models. That is the presentation. We'd be happy to answer any questions. My colleague Brandon is back there as well at the back table. And please come by our booth in the Startup Pavilion. We'd be happy to discuss further. Cheers, everyone. Thank you.
Wow, what a session. Thank you very much, Jason. That was eye-opening. Let's take a few questions. If anyone has some questions from the audience, raise your hand. I'll swing a microphone over by you, and you can go ahead and ask. All right, here we go.
I missed the first few minutes. So how do you get the first batch of data before you can duplicate? Thank you so much.
That's a great question. So we, unlike a lot of companies, are a bring your own data company. So if you have consumer or market research that you are working on, then you would upload it into the platform, and you can use the platform directly. The demo that I showed you is the interface that you can use, of course, with our support. But unlike a lot of generative AI companies, we're the only generative AI company that I know of that does not save your data. So in fact, all of this is run on isolated single-tenant containers that are SOC 2 and ISO 27001 certified, and we do not have access to your data, we can't see your data, we don't save your data. So we do have companies that are working on incredibly proprietary, both formulation or PII-based data on the platform, because we don't have access. The data ownership remains entirely with you, both for the generated data and the uploaded data.
Awesome. Any other questions at all? All right, I'd like to give a lot of thanks to Simulacra Synthetic Data Studio, a bronze sponsor of IFT First, for closing out today's Solution Showcase lineup with a great look at what's next in data-driven innovation. As he said, make sure you check them out at booth S3470CI over in the Startup Pavilion. And before we wrap up, just a very quick reminder. If you did bookmark this session in your app, you're going to get a little reminder to leave a review. This review helps us give us a guide to make sure our scientific program is meeting the needs of the people who come here to First, and we really appreciate your feedback always. If you're interested in more sessions like this, tomorrow we have Exploring the Power of Artificial Intelligence. It is our keynote session. It's called AI Now and Next, Getting Ready for the Future of AI, featuring AI futurist Steve Brown. This presentation will take place at 8:30 a.m. in the Grand Ballroom, and I would suggest you guys don't miss this one. He's really engaging and interesting. And that being said, have a wonderful evening here at First, and we thank you, and thank you for enjoying your first day. Have a good day.